So I thought we'd start with the number talk. So I chose, obviously for kindergarten and first, it's a lot with those subsidizing cards, or it's a lot with your base 10 or your 10 frame cards in those quick flashes. That's just not very interesting for you guys, so I wanted to ramp it up just a little bit. So I'm going to do addition. This would be something that second graders should be moving towards. But some of us that are in upper grades, you'll be like, oh, I don't think my third and fourth and fifth graders could do that. Mm-hmm. So I would always say for everybody, if they've never done the dot cards, I would start all my kids with the dot cards. So that's flashing them as a quick image, such as, I've got these charts over here. On a 10 frame or even not on a 10 frame. So I would start with, this is obviously not big enough for kids, but if I were to flash this for kids on bigger 10 frames, you're holding it up long enough for them to make a mental image, not long enough for them to count. Okay? So like I said, you're holding it up. How many did you see is always the prompt is how many did you see? And then in which ways did you see them? You can even use dice patterns, like dominoes patterns. And again, it's long enough for them to see, but not long enough for them to count. And with a number talk, it's always about recording all of the answers first and then come back for justifying, which you're going to see with an addition problem. Okay? But if I've got fifth graders that maybe like I don't know that they can do that, I would still do that. You can even flash, this might not be quite big enough, but if they were blown up, if we've talked about using the base 10 rods, you can do like an image, like for second grade, I would start building that. How many did I see? So if you have those images, and again, this is drawn like three-dimensional, but literally on mine, like I just draw squares, lines, and dots or X's. And so the only thing I would say is for a quick image, these individual ones, if they're random like this, we're kind of reducing them to have to count, which is not the purpose of it. Like, is there that instantaneous? So I would just take your ones maybe and organize it. This one is literally, like I see these as cards like, can kids literally count and write that number? So those are that kind of instantaneous recognition, and I'll talk about that in a minute. But let's do a number talk because there's common parallels with this, with some additions. So the first problem I'm going to give you is this one. And it's about mental math. So in a number talk, I use hand signals. The number talk books has kids like, if I'm thinking about the problem, I'm holding my hand just chest high. And it's great when it's school-wide because they'll carry it over in their regular math lesson besides that. If I have one solution, then I have one finger up. If I keep thinking and I can think of two ways to explain how to get the answer, I do that. And instead of the kids blurting out or raising their hands, both of which anybody who's still thinking, they stop, right? Because somebody already knows the answer. There's no need for me to continue thinking. Solutions. What did you get?
106.
106. Okay, and again, as kids are doing it, then we can teach them the sign language. Me too, I agree. If I agree with 106, if not, then I'll record something else. Okay, now I'm pretty sure most of us probably got 106. We might not have all done it the same way, but I'll still collect all of the answers because your kids, not all of them are going to agree. Okay, so then it's like, who wants to justify? Okay, so do you mind sharing the way that you got 106?
Sure. So I know 7 and 9 is 16. I know that in 16 there's a group of 10, so I added that in with the 3 and the 6, which are groups of 10, and got 10. So 3 plus 6 is 9 tens, and one more 10 is 10 tens.
Okay, so I'm trying, go back to the first one you said, because as a teacher you should record kind of their thoughts.
7 and 9 is 16. I know in 16 that there's a group of 10. I know that 3 tens and 6 tens is 9 tens. I added the extra 10 from the 16. We got 10 tens.
Okay.
So 10 tens is 100, and then 6 ones are 106.
Okay. Now, what I appreciate is that you had the tens, because when kids just tell me 3 plus 6 equals 9, I literally write 3 plus 6 equals 9, because they're weak in their place values. So if we've taught only traditional algorithms and they're just recording things as digits, then the traditional algorithm does not support the building of place values. So you really, like, I'm so glad you said that right off the bat as a great model for it. Okay, now, again, we might have an I agree because I did it the same way. Did anybody actually do it a different way? Okay, back here.
From the 37 and turn 69 into 70, so I have 7 tens and no ones. So 0 ones and 6 ones is 6 ones, and then I have 7 tens and 3 tens is 10 tens.
Okay.
And tens and 6 ones is 106.
Okay. Anybody do it yet a different way? Okay.
I took my tens first. I added 30 plus 60.
Okay. You guys might not be able to see over there.
And I got 9 tens and 90.
Okay.
And then I took my ones and I added my 7 plus 9 is 16.
Okay.
And 16 has 110 in it. So
Okay.
I added that to the 90. That is 100. And then I had 6 ones left. So, and added those together.
Okay. Now, and you guys, this is, we want our second graders to start to do this. Now, they might not be ready for this big of a number, but this is like, some of you guys are seeing how do I build towards landmark numbers? And this is where I would say Expressions does a really terrible job of any kind of routine. So think back to those counting routines where I might start with, if I give you 37, how many more do I need to get to the next decade? Or if I'm at 69, how many do I need to get to the next decade? Which, backing down to, kindergarten, but we were counting by tens and we just turned it into a game. If you say 100, you got to sit down. So it's like duck, duck, goose, but the opposite direction. So they were counting around in a circle by 10. Whoever said 100 had to sit down, and we keep counting by tens. So from kindergarten, just as that progression, like, if they can't count by tens, they don't even know what their decade numbers are, right? And then by the time we get to second grade, it's how many more do I need to get to that group of 10 so that I have this flexibility with quantity, okay? Now, if we were to continue with the number talks are traditionally around 10 minutes. I always have to set a timer because I'm probably well past 10 minutes already. And there's a sequence of problems. So in the book, Number Talks, this was the first problem. I just want you guys to see kind of the sequence of problems because this was all about landmark numbers. So if you follow the problems that are actually in that particular book, they're very sequenced. And I did like a level 3 for you. Like there's level 1 problems, there's level 2, and there's level 3. But the sequence was this. As a teacher, you're just recording their thought process, literally recording what they have. So the sequence was 79 plus 26, and then 89 plus 28, and then 99 plus 19, okay? And so what I like, this idea of if I take one and give it to the other one, this like little compensation piece, then it makes this a nice number where I don't have that regrouping with my ones anymore. I've made this a nice number, a nice decade number. Which just means tens can go with tens and I know exactly how many ones I have. Okay. Otherwise, this is a ton of regrouping for a second grader. Lots of chance for errors. How many of our second graders are struggling with what 9 plus 7 is in the first place? Right? So are we building it as 6 plus 10? There's that scaffolding up for them. What you got to see with Kinder is we did some things where are they recognizing all of their 8s and 9s? Like these were all at the top, and I'm showing this because it could have been something we would have used in 5th grade as well, or definitely for 3rd grade, where like these are numbers in their set, but if I have different representations, can they put them in their right houses? And again, I chose kindergarten numbers, but these could have been 2nd grade numbers, they could have been fractional values, they could have been all sorts of things. I even said for 2nd grade, they could have been, and I love it that you've got these cards. So I have cards that this is a matching game. At least I think this is set up as a matching game. But I've got this card with, again, you could use note cards and double stick tape or something like that. Where it's this, I might have a house that's less than 200 and a house that's greater than 200. So it's not always about just the number, but now I've upped the rigor a little bit to say, hey, how is this number, where does this number live if this house has to have everything less than a value or greater than a value in a different house? So there's lots of ways you can change up that number sense piece with, we've got this one particular activity, where do I place them? And again, it doesn't have to be Post-it notes, because this could have been just on their tabletop. And if I make generic houses, I can laminate it and then write in it what I'm going to do, and then it's just their place in their cards. It's really a sorting mechanism. So if that is a way that can help your kids, I would definitely do something like that for number sense. So you know the game that we did with the snap cube? Okay, so there's like 3 games that I would play and make them like next week all about the same number.
Oh, okay.
So let's say your kids, like, do they know their combinations to make 6?
Right, yeah. Well,
If
yeah.
Okay, so if they don't, the next week the number is 6. So the linking cube things, the hide the cubes, that is a great game to play. Another one would be to, and again, I can send this template if I haven't already. So it's like these little bullseyes. The whole page has all these bullseyes. So if you're playing for 6, I'm trying to do 6. So the kids roll a number, I roll my dice, I get 5. What's the partner to make 6? So it's another like missing add-in thing. But like, let's say I'm trying to get to 12 now, right? Like I'm second grade, that hard part is getting from 10 to 20.
Right.
So now they might have to roll 2 dice. So I roll my 2 dice, now I'm working on number combinations yet besides. I rolled a 6 and a 1 or a 3 and a 4.
Right.
What is that? Now 7 needs what more to get to 12, okay? So that's one piece, or that's the second one. The third one would be the flip chips. You guys, most of you guys have 2 color counters. They're red on one side. So again, that center where you might have, there's, if the number's 12, put 12 in a baggie or in a cup. They're shaking them, dropping them, and make them build that number mountain or a number sentence with it, okay?
And just take like one number for the week.
One number for the week, one number for the week, one number for the week. The other thing that I would do from 10 to 20, because this is going to impact 3rd, 4th, and 5th at the same time, would be, do I take another week and build some games around doubles? And if you just Google, or even in those North Carolina games, I feel like there's some in there. Yeah, the North Carolina games have a lot of things, especially in 1st and 2nd, about like doubles or doubles plus 1 strategies, or a plus or making 10 strategy. So if kids are doing this, if I'm going to think make 10, right? If I'm going to get to 10, 7 needs 3 more to get to 10, and then 2 more from 10 to 12. So that means I'm going to need 5 more. So you want to start, let's not count on our fingers. Tuck your fingers underneath. Forces their hands off the manipulatives, you know. And so let's think 10. How many did I need to make 10 from 10 to 12? And so here again, kinders, like I know you haven't gotten there in kinder yet, but this idea of decomposing a teen number is massively important for 1st and 2nd grade with all their strategies. That they understand 12 is 10 and 2 more, or 10 and 2 more makes 12. Both directions, can they tear those apart? Okay, which the Rec and Recs are a beautiful model for. Yeah, well, no, you can say 72. So because they said it that way, I wrote it in words, but I was anticipating somebody saying, so I turned this to 70. And so if somebody would have said, I took one from here, and so I changed the problem into 36 plus 70, and then I know 30 plus 70 equals 100, and then I have 100 plus another 6, I would have, as sloppily as that is, I would have written it like this. But because they said 7 tens, I wrote it that way.
So it's okay to say
Absolutely, absolutely, yeah. Because that still tells me that they realize that this is in the tens place. And it's not just 3 plus 6 equals 9. If they're going to tell me 3 plus 6 equals 9, I will write 3 plus 6 equals 9. And I'm like, well, how does a 9 go with a what did we have before? 16. Like I thought 9 plus 16 was 25. So it really makes them question, like, what really is that? And they're like, no, just write it here. Well, how do I know to write it there? Like that's that place value piece that we've got to get better with.